This is the step-by-step answer key for Chapter 13, Tap number 1. And I've got the graph here, and we see that the marginal cost of each extra day in the hospital is $1,200. And David's valuation of each day, the marginal value of each day, is given by this following function. And so David, left to his own devices, no insurance coverage, would stay every day for which his value, his willingness to pay, was greater than the cost that would be charged to him. So he'd stay, left on his own, 3 days. Now, Part A doesn't ask about that case. It asks about the case where David has insurance that fully covers the cost of hospital stays, and then his premiums aren't dependent to his use. So he's got first dollar coverage. In that case, the cost of one extra day's stay to him is 0. So he'll stay every day as long as there's any value greater than 0, and in this example he'll stay 9 days. I think I've got a bit more elaborate text answer to this problem, but that's the gist, and I'll leave it at that. Let's move on to Part B. That's where the more interesting work in this tap has to be done. And then Part B, I've shrunk this so I can have the graph, Part A and Part B, in view. Now we have this question: by how much would total economic surplus have been higher this year if David's hospital insurance provided no coverage for the first $1,200 spent on each hospital stay, then covered 50% of any charges over that amount? Now this $1,200 deductible is coincidental. It's got nothing to do with the marginal cost function, but we can consider David's price of hospital stays. So he's got no coverage for that first $1,200, so he's going to be paying full price for that first $1,200. But then his deductible limit is met, and the insurance company pays 50% of everything after that, and that means $600. So now the price David sees is, we'll just call it P sub David, and that's the price of the procedure less what his insurance covers. That's what he's going to have to pay out of pocket. Well, now he's going to stay 6 days. So David stays just 6 days. Now we could do, consumer surplus, producer surplus, etc. We could do that analysis, but it's going to turn out to be easier to answer this question: by how much would total economic surplus have been higher this year, if we just take a tack at this answer to think about how much deadweight loss has shrunk. Because deadweight loss, we know, is the difference between whatever surplus we've realized in the outcome we're talking about and the socially best outcome. So that socially best outcome is where every day that's valued, every day's stay that's valued at least as highly as its social cost is stayed, but no more than that. So every day's stay after 3 costs society more than its benefit to David or to anyone else. All right, so in that first case, we had deadweight loss, and this closely mirrors the exposition in the text. The deadweight loss of that stay is this big green area. We're counting the excess of costs over benefits. For each day's stay, we're adding them up over all the extra days stayed, and it's this big green triangle here. Now I'm going to change colors, and let's find something that goes with that. I guess let's just do red. Christmas is coming, green and red. Now, when he stays 6 days, deadweight loss is only this smaller red triangle. So we've eliminated a big chunk of deadweight loss. If we count that up, that's going to answer our question. That's how much total surplus is going to be higher. So let's we have increased total surplus by, and then let's do some calculations. The easiest way to get this area, I think, is the way most of you did it in class. And that's to take this big triangle's area and subtract off this triangle's area. We're going to do that. So this big triangle is 6 days. The base is 6 days. He stayed 9. The optimum was 3. And it's 1,200 high. So 1/2 times base times height gets us to 6 times 600. 3,600 is that level. And we're going to subtract off this area. This area is 3 days. The base is 3 days. The height is 600. So 3 times 300, 1/2 times base times height, 900. And that's just going to equal $2,700 per illness, we'll say, per appendectomy. He'll only have one appendectomy, so that limits the damage. But this whole calculation happens when he has heart trouble or breaks his leg or whatever. All right, that's where that answer comes from.